They are not clear. They are not the pristine high-definition glossies you see on NASA's front page. They are grainy, artifact-laden, and deeply unsettling. They are composites, strings of data translated into visual information leaked from secure servers and passed around on encrypted networks. And they all show one thing, 3i Atlas. This is not a story about grainy footage from the 1970s. This is happening right now in November 2025. As you read this, an object from interstellar space is passing through our solar system. Its official designation is 3i Atlas. The 3i means it is only the third interstellar object humanity has ever confirmed. The first was Oumuamua, a bizarre cigar-shaped rock that tumbled past us in 2017. The second was 2i Borisov, a more familiar-looking albeit alien comet. This third visitor, 3i Atlas, is different, and it is the subject of a quiet, frantic and terrifying crisis within the astronomical community. When it was first detected by the Atlas Observatory in Hawaii earlier this year, it was just another faint smudge moving against the background of fixed stars. Its trajectory, however, was immediately flagged. It was moving too fast. Its path was a wide hyperbolic curve, a clear mathematical signature that it did not originate here. It was a visitor from the void. At first, the observations were routine. Telescopes around the world, including the massive arrays in Chile and the orbital platforms, were pointed at it to gather data. The plan was simple: get spectral readings, determine its composition, measure its speed, and write a few dozen papers on another curious visitor. Then the data started coming in, and it made no sense. This is where the silent crisis begins. While the mainstream media and official space agencies remain utterly silent, the specialized forums, the private message boards and university subchannels, where astrophysicists and sensor technicians actually talk, are on fire. The problem is the leaked images. The problem is the data behind them. The first set of images to leak were light curve readings. This measures the brightness of an object over time. For an asteroid, it usually reveals its rotation a simple repeating pattern of bright and dim. For a comet, it's more complex, flaring up as pockets of ice are vaporized by the sun. The light curve for 3i Atlas is neither. It is complex, yes, but it is also regular. It shows a pattern of brightening and dimming that seems almost artificial. It is not the chaotic random outgassing of a tumbling block of ice. It is a precise repeating sequence. This data leaked from a European Southern Observatory feed was the first red flag. It was data that should not exist. Then came the spectrographs. This is how scientists determine what something is made of by looking at the light it reflects. The readings from 3i Atlas are a mess. They show traces of water ice and silicates as expected, but they also show processed metals, elemental signatures that have no business being on the surface of a natural comet. This data was dismissed as instrument noise and sensor contamination by the official channels, but the noise kept showing up from different telescopes at different times. The final straw and the source of the most shocking photographs was the radar data. Using the most powerful planetary radar systems on Earth, astronomers bounced signals off 3i Atlas as it neared its closest approach. You cannot photograph an object this distant in detail. You can only build a model from the signals that return. The models built from the 3i Atlas radar pings are the images that are causing the panic. They do not show a fuzzy, vaguely potato-shaped rock. They do not show a porous cloud of ice and dust. They show structure. They show sharp angles. They show a surface that is unnaturally smooth with an albedo, a measure of reflectivity that is far too high. They show something that is clearly unambiguously not a comet. These images, grainy and difficult to decipher as they are, do not depict a natural object. This is the core of the conflict. The mainstream media and NASA are completely dark. Go to their websites. There are no press releases, no Object of the Week features. There is nothing. The most significant astronomical event of our lifetime is happening right over our heads, and the official public-facing sources are pretending it isn't there. This is not a conspiracy theory. This distinction is crucial. A conspiracy theory is built on a lack of evidence, a belief that they are hiding something. This situation is the opposite. It is an argument driven by a surplus of evidence. The problem is that the evidence itself is impossible. It points to a conclusion that is so foundation-shattering that the institutions we trust to tell us about the universe are for now choosing to say nothing at all. This isn't a failure of observation, it's a failure of nerve. The silent crisis is being fought by PhDs and postdocs, by men and women who have dedicated their lives to the scientific method. They are not on UFO websites, they are on astrophysics forums, and their debate is technical, fierce and desperate. They are not arguing about aliens, They are arguing about why the spectral lines for magnesium are showing up in a pattern that implies non-natural heating. They are arguing about how the object's trajectory appears to have undergone a tiny non-gravitational course correction before it reached perihelion, the point of its closest approach to the Sun. A comet can be pushed by its own jets of melting gas, but the data from 3I Atlas shows a change in velocity that is not matched by any observed outgassing. The leaked images are not being dismissed as fakes. They are being furiously debated. That's a processing artifact from the new deconvolution algorithm, one side argues. The algorithm is sound, the other side replies posting pages of math. The signal-to-noise ratio is too low to confirm the albedo. It's low, but it's consistent across 4 separate observation runs. This is the sound of scientists who are looking at data that contradicts a lifetime of learning. This is the sound of panic. We are in a unique and terrible position. The observable data, the photos, the graphs, the numbers all point to the fact that 3I Atlas is not what it is supposed to be. It is not a rock, it is not a comet, it is something else. Before the images, there were the numbers. Long before any camera was close enough to see 3I Atlas as anything more than a moving pinprick of light, it was already causing problems. In astronomy, problems are just another word for mysteries, and this object was collecting them at an alarming rate. It began its life in our notebooks not as a discovery but as a puzzle. This wasn't a case of a single dramatic clue. Instead, it was a slow, creeping accumulation of oddities. It was like a detective looking at a suspect whose story just didn't add up. One small inconsistency is a mistake. 5 of them all pointing in a strange direction is a pattern. This collection of data gathered from the telescopes across and above the Earth became the documented mystery of 3 Atlas. The very first clue that something was off was its colour. This might sound simple, but to an astronomer the colour of a distant object is its autobiography. It tells you what it's made of and what it has been through. Most comets we know, especially those from the cold distant edges of our own solar system, are very reddish. This distinctive red-brown colour is thought to come from a complex layer of organic molecules, a bit like tar, that covers their surface. This Seegunk is built up over billions of years as ice and carbon compounds are bombarded by cosmic rays. 3 Atlas had the wrong colour. It wasn't just less red, it was a dull, almost neutral grey. It lacked the chemical signature that screamed Comet. This was the first major red flag. A grey surface suggested something else entirely. Was it a chunk of bare processed rock? Did it lack the organic materials we thought were universal? Or perhaps it came from a place where the surface was constantly being scoured clean, or where the gunk was never created in the first place. This simple colour measurement was the first piece of the puzzle that refused to fit in the box. The second puzzle was its heartbeat, or more accurately its light curve. As a comet spins, we see its brightness change, just like seeing a mirrored ball turn in the light. If it's a stable potato-shaped object, it will produce a very regular, predictable pulse of light. We can watch this flash and determine exactly how fast it's spinning, and even get a rough idea of its shape. 3I Atlas's light curve was a mess. It wasn't a stable pulse, it was a chaotic flicker. The brightness varied wildly, not over a few regular hours, but in a complex tumbling pattern. This suggested it wasn't spinning neatly on an axis at all. Instead, it seemed to be tumbling end over end through space. This is exceptionally rare. A tumbling state usually means an object just suffered a massive collision or a recent violent event. For an object cruising in from interstellar space, it implied a chaotic and unstable past. Furthermore, the variations suggested extreme differences on its surface. It wasn't just a lumpy potato. It was as if one side was brilliantly reflective and the other was as dark as coal. This sharp divide, or albedo difference, was far more extreme than anything we'd seen on a typical comet. Then came the explosion. On October 31st, telescopes monitoring the object registered a massive sudden increase in brightness. In just a few hours, 3I Atlas became several times brighter than it had been. Now, comets do have outbursts. Pockets of trapped gas or ice beneath the surface can heat up, burst through the crust and create a jet, temporarily making the comet glow. But this event was, as the prompt noted, ill-timed and puzzling. The outburst happened when 3I Atlas was still incredibly far from the Sun, much farther out than where the Sun's weak light could typically sublimate water ice. The engine that powers most comets' water ice turning to gas should have been frozen solid. So what caused the explosion? Something else must have been vaporizing a much more volatile ice, like frozen nitrogen or carbon monoxide. But even that didn't fully explain the energy released. It was too much, too fast and too cold. It was a Halloween surprise that defied our thermal models and added another layer of high strangeness. As it moved closer, our instruments got their first good sniff of its atmosphere, the cloud of gas called the Comet. We did this by looking for the chemical fingerprints of different molecules. The one we always look for first is water. We don't usually see water H2O directly. We see its breakdown product hydroxyl OH, which is an oxygen and a hydrogen atom bound together. Sunlight breaks the water molecules apart and the hydroxyl glows in a way we can measure. The hydroxyl signature from 3I Atlas was doubly confusing. First, there was simply too much of it. Based on its size and the amount of dust we could see, it was producing water vapor at a truly prodigious rate. It was behaving like a much larger, more active comet. Second, the distribution was weird. Normally the hydroxyl forms a relatively uniform halo around the nucleus as the water ice boils off from all over the sunlit side. On 3I Atlas, the hydroxyl signature seemed to be clumpy or perhaps jetted from very specific localized spots. It wasn't a gentle boil, it was a set of pressurized geysers. This implied a very unusual internal structure, one where heat was being channeled in strange ways to create these powerful water-rich plumes. But the final and perhaps most bizarre clue was the one that broke all the rules. Comets change as they fly past the sun. The intense heat and solar wind is a trial by fire. This process, called baking, boils off the fresh volatile ices from the surface, leaving behind the darker, dustier and redder materials from beneath. The rule is simple: comets get redder and duller after they pass perihelion, their closest point to the Sun. 3I Atlas did the opposite. As it flew away from the sun after being cooked at millions of degrees, it began to change colour again. But it didn't turn red. It developed a faint but unmistakable blue tint. This was, to put it mildly, impossible. A blue colour is almost never seen on the solid surface of a comet. While a comet's gas tail can glow blue from energised carbon monoxide ions, the nucleus itself should not. A blue surface implies a specific kind of material, perhaps fine-grained water ice or exotic minerals, was being exposed by the solar passage. But this would mean the comet's interior was fundamentally different from its exterior in a way we had never anticipated. It was as if baking a loaf of bread turned the crust into blue candy. To truly understand how strange this object became, we must first look at what it was before. We need a baseline image, a before picture, to provide context for the after. We are lucky to have one. Back in September, long before the object began its most dramatic and puzzling behaviours, the Gemini South Telescope in Chile, a powerful observatory, took a snapshot. The image it captured was, by all accounts, perfectly normal. It showed a faint fuzzy object with a slight reddish-brown tint consistent with the dust and complex organic molecules found on a typical comet. It had a developing coma, the gassy, dusty cloud around its core, and looked exactly like what astronomers would expect from a small icy visitor from the outer solar system. This September image is perhaps the most important piece of data we have because it proves that the object started its journey past our Sun as a normal comet. It was not some strange alien-looking thing from the very beginning. It was a standard-issue dirty snowball. This baseline makes the bizarre transformations that followed all the more shocking, as they represent a complete deviation from this normal, predictable starting point. The trouble began when the data stopped matching the textbooks. The anomalies were not minor. They were fundamental, challenging the very physics of how comets are supposed to work. Let's start with the colour. This was one of the first and most baffling clues. As the object got closer to the sun, it began to change colour, but in a sequence that makes no physical sense. Observation showed it shifting from red to grey and then to blue. This is precisely the opposite of what should happen. A normal comet's colour is dictated by what is boiling off its surface. When it's far away, it's usually reddish-brown, the colour of the dirt dust and complex carbon-based molecules on its surface. As it gets closer to the sun and heats up, it can sometimes develop a greenish tint in its coma, a specific glow from gas, like diatomic carbon being energised by sunlight. It can also develop a blue tail, which is not the comet itself, but gas-like carbon monoxide being ionised, given an electrical charge by the sun's particles and pushed away by the solar wind. The Object 3A Atlas did none of this. Its core itself, the central condensation, shifted colour. The red to grey to blue sequence is baffling. A red colour implies dust. A blue colour implies something like a high concentration of carbon monoxide ions. For it to go from red dusty to grey, a neutral mix perhaps, and then to blue gassy ionised, suggests it somehow shed its dusty outer layer. Then, what became something neutral? and then transformed into a body dominated by a process that creates a blue glow. There is no known heating model that explains this. It's like watching a log in a fire turn from a burning red ember to a grey piece of ash and then back into a glowing blue gas flame. It defies the expected chemical and physical progression. Next came the puzzle of its brightness. The object suddenly flared, becoming dramatically brighter over a very short period. In comet science, there is a standard go-to explanation for this fragmentation. The theory is simple and well established. A comet is a loosely packed ball of ice and rock. As it heats up, the stress can cause it to crack and break apart. When it does, it's like smashing a geode. Fresh untouched ice from the comet's interior is suddenly exposed to the raw power of the sun. This new ice vaporizes or sublimates incredibly fast, releasing a massive cloud of gas and dust. This new large cloud reflects much more sunlight, and from Earth the comet appears to have a sudden brilliant outburst. This fragmentation hypothesis was the immediate assumption for 3i Atlas. It had to have broken up, but then the new images came in. High-resolution telescopes were pointed at the object after the brightening event, expecting to see a string of pearls, a trail of smaller pieces, or a messy diffuse cloud where a single object used to be. Instead, they saw the object apparently still intact. It had not shattered. It was still a single concentrated point of light. This is a profound contradiction. We had the effect of massive brightening without the cause of the physical breakup. It's like hearing a building demolition explosion and seeing the dust cloud, but when the dust clears, the building is still standing completely unharmed. If the comet didn't break apart, what caused the flash? What process could release that much material so suddenly while leaving the main body intact? The data from the brightness curve and the data from the images were in direct conflict. Finally, there was the water. Using spectroscopic analysis, a way of reading the light fingerprint to see what an object is made of, scientists did detect water. This itself is not strange. Oh, comets are full of water ice. The strangeness was in its signature. When a comet sublimates, the ice turns to gas more or less uniformly across the entire sun-facing side. This creates a large, fuzzy, roughly spherical cloud or coma. But the water signature from 3i Atlas was not a uniform fuzzy cloud. It was described as directed. Think of it this way. A normal comet is like a block of dry ice with fog rolling off its entire surface. The signature from 3i Atlas was like a jet or a geyser. The water vapor appeared to be shooting out from a specific concentrated point on the object in a specific direction. This is highly unusual. While comets do have jets, they are usually part of a much larger general sublimation process. This observation suggested a very different mechanism, as if a powerful focused vent was releasing water from deep within the object, rather than the whole surface simply fizzing away. This directed water jet does not fit the dirty snowball model cell, which remains the foundation of comet science. This collection of anomalies was so persistent that it wasn't just one team pulling their hair out. The strange data was being confirmed by other organisations and observers around the world, which only deepened the mystery. The European Space Agency, ESA, using its own assets, was monitoring the object. They noted what they called spectral inconsistencies as 3i Atlas approached the orbit of Mars. This is scientific language for its light fingerprint looks wrong. The spectrum, the breakdown of light that tells us what something is made of, was not matching a typical comet. It was changing in ways that were hard to explain, or it was showing a chemical makeup that was not consistent with what we expect from an object from that part of the solar system. Their data confirmed that the object's very chemical nature was either in flux or was simply not what it was supposed to be. At the same time, highly skilled amateur observers in Japan who spend thousands of hours tracking comets and know their behaviour intimately began reporting irregular coma development. This is a crucial on-the-ground observation. They were seeing the fuzzy cloud around the comet grow in lopsided, clumpy or irregular ways. This real-time visual data provided a perfect match for the directed jet anomaly. If a single powerful jet is shooting out one side of the object, it would absolutely create an irregular, non-symmetrical coma. This is where the data stands. We have a baseline before picture from the Gemini South telescope showing a perfectly normal comet. And then we have the after, a cascade of technical data and visual observations confirmed by multiple independent groups, showing an object that defied comet physics. It changed colour in the wrong order. It brightened like it broke apart, but looked like it was fine, and it shot out water like a cannon instead of fizzing like a snowball. The real story, the one that would eventually overshadow all the official scientific reports, did not begin in a sterile laboratory or at a government press conference. It started as so many strange things do on the fringes. The date was approximately November 3rd. The object had already made its closest fiery pass by the Sun, its perihelion, and was now heading away, beginning its long journey back to the darkness. The peak professional observation window was for all intents and purposes over. The major telescopes had gathered their data and the scientists were settling in for the long, slow work of analysis. But the amateurs were still watching. The source of the images was not NASA, not the European Space Agency, not any official body. If it had been, the images would have been cleaned, sanitized, peer-reviewed and accompanied by a careful, measured explanation. These were not. They came from small independent observatories and dedicated amateur astronomy networks, groups of highly skilled individuals who often pooled their resources to buy telescope time or process data in ways the official channels would not. These images, raw and unsettling, spread first through encrypted message boards and specialized data-sharing forums. They were not leaked from a government source in the traditional sense. Rather, they were a release from a community that felt the public had a right to see what they were seeing, a community that was watching the official silence with growing suspicion. The images themselves were grainy, difficult to interpret and process to within an inch of their lives. They were composites, the result of stacking hundreds of individual frames to pull a faint signal out of the overwhelming noise. But what they showed, or what they seemed to show, was explosive. The claims that emerged from these images were specific, testable, and deeply troubling. The first and most immediate claim centered on the object's shape. It was wrong. Comets and asteroids are sculpted by random collisions and the uneven melting of ice. They are lumpy, potato-shaped, irregular. They are natural. The object in these new images was not. Observers pointed to structures that were too straight. In the enhanced high-contrast images, one could make out what appeared to be edges, long linear boundaries that looked less like a cliff face and more like the side of a building. There were sections that seemed to show symmetry. We are not talking about the perfect bilateral symmetry of a butterfly, but a geometric repetition that felt deeply unnatural. There were facets and angles that looked, for lack of a better word, manufactured. A normal space rock might have one straight-looking edge by pure chance, but to have multiple repeating geometric structures that was statistically wildly improbable. This was, of course, the easiest claim for skeptics to attack. But it was the one that captured the public imagination. It was the face on Mars all over again, but this time the face was a kilometre-long geometric anomaly. The second claim was far more technical, and for the scientific community far more terrifying. It involved the coma, the massive glowing cloud of gas and dust that boils off the object as it is heated by the sun. This cloud by its very nature is opaque. It is a thick, soupy fog. Any light from the solid surface or nucleus must travel through this dense fog to reach our telescopes. This means the dust and gas should block and scatter the light, a process known as occultation. You should not be able to see the surface clearly through the densest parts of the coma. It is, according to our understanding, physically impossible, yet the images claimed to show exactly that. In several frames processed by different groups using different software, the same anomaly appeared. You could see the bright, energized cloud of the coma, but you could also see the dark, sharp edge of the object behind it. It was as if you were looking at a ghost. The surface was visible through the very atmosphere it was creating. This observation was a direct challenge to the laws of physics. What could possibly explain it? The forums lit up with theories. Was the coma not a uniform cloud at all, but a series of highly directed jets or vents that left clear patches of space? If so, that would imply a non-natural controlled process. Or was the object itself emitting some kind of energy that made the surrounding gas transparent in a way we had no model for? The implications were staggering. If the images were real and not a bizarre processing error, then our understanding of cometary physics was wrong, or the object was not a comet. The third claim was just as strange and just as rooted in precise observation. It challenged all our models of rotation. Everything in space spins. As an object like this tumbles through space, different parts of its surface are lit by the sun. A specific point, a mountain, a crater, a reflective patch of ice will get brighter as it rotates into sunlight and then dimmer as it rotates into darkness. By tracking these changes in brightness over time, astronomers create a light curve, which tells them how fast the object is spinning, and even gives a rough idea of its shape. The official teams had already released a preliminary rotation model, but the new images contradicted it. The amateur observers tracking the object for hours at a time noticed something that the official short-exposure snapshot images might have missed. Specific features on the object's surface maintained a consistent relative brightness. While the object as a whole clearly rotated with its overall shape changing as expected, certain spots did not seem to dim. They remained bright even when the rotation model said they should be facing away from the sun, or at least be at an oblique dimmer angle. It was as if these spots were not just reflecting sunlight, it was as if they were lights themselves. Or perhaps they were massive flat metallic surfaces perfectly angled to act like mirrors gathering and reflecting sunlight in a way that no natural rock or ice formation ever could. This brightness consistency defied the simple model of a tumbling inert rock. It suggested the object was either not a simple rock, or it was actively managing its light profile. This combination of claims, unnatural geometry, impossible physics in the coma, and non-rotating bright spots created a firestorm. The debate was immediate and fierce. The pushback from the mainstream scientific community, and even from more conservative amateur astronomers, was predictable. They argued quite reasonably that these were not real features. They were processing artifacts. When you take a very faint signal from deep space and amplify it thousands of times, you introduce noise patterns and errors. The straight edges were just the result of the specific computer algorithms used to sharpen the image. The see-through coma was a ghost, an echo in the sensor, or a result of stacking images taken at slightly different times. And of course there was the powerful argument of pareidolia. This is the psychological phenomenon where the human brain finds meaningful patterns in random noise. We see animals in clouds' faces in burnt toast, and critics argued we see alien structures in blurry astronomical images. People wanted to see something extraordinary, so their brains dutifully interpreted the random digital static as geometric, manufactured, and purposeful. But the observers who had captured the data held firm. They rechecked their work. They ran different algorithms. They shared their raw, unprocessed data for others to analyze. And time after time, the anomalies remained. The artifacts they claimed were part of the signal itself. This entire debate, however, orbited a much larger, darker mystery, the central puzzle of the entire event. This was the absolute deafening silence from the major organizations. NASA, the ESA, the Russian, Chinese, and Japanese space agencies, the major universities with their world-class observatories, they all had telescopes and sensors far more powerful than anything the amateurs possessed. They had data from space-based telescopes free from the blurring effects of Earth's atmosphere. They had been tracking this object for months. They had to have seen what the amateurs were seeing, and they must have seen it with terrifying clarity. Yet they said nothing. They did not issue a statement confirming the anomalies, but just as telling, they did not issue a statement denying them. A simple denial would have ended the speculation overnight. A press release stating, "We have reviewed the amateur images and can confirm they are processing artifacts. Our own data from the Hubble Space Telescope shows a perfectly normal cometary nucleus," would have been all it took. The leak would have been dismissed as fringe paranoia, but they did not do that. They also did not confirm it. They simply remained silent. This silence was interpreted by the online communities in the most chilling way possible. It was not the silence of dismissal. It was not the silence of slow, careful bureaucracy. To many it felt like the silence of fear. It was the silence of people who have seen something so far outside their frame of reference that they have no idea what to say. The lack of a denial was taken as a confirmation. The organizations that we trusted to be our eyes and ears on the cosmos were now mute. They were not debunking the claims, nor were they validating them. They were just quiet. And as the strange object continued to pull away from the sun, fading back into the dark, that silence became the loudest, most terrifying signal of all. When we analyze the unusual claims about this comet, we must test them against the known laws of physics. Many of the proposals for a mystery object are difficult to support because they require us to ignore or rewrite fundamental principles of how comets' light and gravity work. The first issue to consider is the geometry problem. The strange shapes and patterns seen in comet homes were not just the result of one person at one telescope. They were reported by many different independent observers all around the world. These were amateur and professional astronomers in different countries using completely different equipment. One person might have a telescope that isn't focused properly. Another might have a digital camera, a CCD sensor with some hot pixels that create false stars. A third person might use a specific photo editing program that creates an artifact, a sort of echo or halo when they try to sharpen the image. All of these things are individual processing errors. If only one person had captured a cigar-shaped object or a disk inside the comet, scientists would correctly blame it on one of these personal errors. However, that is not what happened. Dozens of people all separate from each other, began posting images that showed similar patterns. If one person in France sees a specific shape and another person in Arizona using a different brand of telescope and camera also sees that same shape, it becomes very difficult to say it's just a personal error. The probability that all of them independently made the exact same mistake in focusing, tracking, or processing is almost zero. This agreement from different locations, which is a form of triangulation, implies that the source of the light, the comet itself, was producing this pattern. It significantly reduces the chance that it's just an illusion and suggests the patterns, whatever they are, must be originating from the object, Shutterstock. This leads to the second major issue, the dust layer problem. The core claim of many theories is that these images show a solid surface through the comet's surrounding cloud, which is called the coma. From a physics standpoint, this idea is highly unlikely, verging on impossible. A comet's coma is not a thin, transparent fog. As the comet nucleus, the solid ice ball, gets warm, it releases enormous quantities of gas and dust. This cloud is what we actually see. It can expand to be millions of kilometers wide. Near the center, this cloud is incredibly dense and opaque. It's a pea soup fog of tiny dust particles and gas molecules. When we take a picture of a comet, we are not seeing the solid nucleus. We are seeing sunlight reflecting off this massive, dense cloud of dust. The brightest spot in the middle is not the surface. It's just the densest part of the fog. Claiming to see a distinct surface through this coma is like standing on a boat in a hurricane and claiming you can see a specific grain of sand on the ocean floor 10 kilometers below you. It's absurd. For us to see the nucleus, the coma would have to be completely transparent. But if it were transparent, it wouldn't be releasing dust or gas, and therefore it wouldn't be a comet. To see the surface as claimed would require a completely new, unknown type of comet physics, where the coma is somehow invisible or non-existent even while it is clearly visible and expanding. Next is the brightness problem, which reveals contradictions in the object's rotation. Almost every object in space, from planets to tiny asteroids, rotates. If the object inside Holmes was a solid structured craft or rock, it would also be rotating. As it rotates, we would see different sides of it. This would cause its brightness to change in a predictable periodic way. This is called a light curve. For example, if it was a long cigar-shaped object, it would look bright when we see its long side and dim when we see its narrow end. If it had a large shiny spot on one side, it would flash at us with every rotation. The problem is the images showed a relatively stable, consistent shape and brightness. This implies two possibilities, and both are extremely unlikely. The first is that the object is spinning incredibly slowly, perhaps only rotating once every few weeks or months. This is very rare for a small body in the solar system, which typically spins on a timescale of hours. Such a slow spin is hard to explain. The second possibility is that the object is tidally locked, meaning it always shows the same face towards us, just as our moon always shows the same face to Earth. But tidal locking is a gravitational effect that happens over millions of years and requires a massive primary body like the Earth to lock to. Comet Holmes is just flying through the solar system. It isn't orbiting anything that could lock it. Both implications for its dynamics, either a near impossible slow spin or a physically impossible tidal lock, make the solid object theory very difficult to believe. Perhaps the biggest physics contradiction is the before and after problem. Comets orbit the Sun, and the point of their closest approach is called perihelion. This is where they receive the maximum amount of heat and solar radiation. Physics dictates that this intense heat should cause the comet to become more active, releasing more gas and more dust. The coma should become larger, denser, and foggier. The images from September before the main event showed a typical fuzzy and diffuse comet. The main outburst happened in October, and the controversial sharp images were taken in November, after the comet had passed its perihelion in May, and then had its massive outburst. The claim is that this after picture November is clearer and sharper than the before picture September. This is the exact opposite of what all known comet physics predicts. Going through perihelion and having a massive outburst should make the object fuzzier and more obscured by a massive cloud of new debris, not cleaner and more defined. It is like saying that flying a snowball closer to a flamethrower made it more solid and less melty. This breaks the fundamental cause and effect of solar heating. To try and solve this before and after contradiction, an alternative hypothesis was proposed: the perihelion pass, or the outburst itself, acted like a peel, stripping off a volatile outer layer and revealing a different structure underneath. The idea is that the September image was indeed a normal fuzzy comet covered in a thick layer of ice and dust. Then the outburst, the event, was so violent that it blew this entire outer layer clean off into space. The after image from November therefore is not a comet. It's the core or structure that was underneath the ice layer all along. This explanation sounds clever, but it just creates new, even bigger physics problems. First, a comet's nucleus has almost zero gravity. A peeled layer wouldn't just vanish, it would become the new coma. The peeled material is the dust cloud that would hide the nucleus, so this doesn't solve the dust layer problem. Second, comets don't have an off switch. Even if a layer was stripped away, the newly exposed core would also be heated by the sun and would immediately start turning to gas, creating a brand new coma. You cannot have a naked ice or rock core sitting in the inner solar system without it producing a cloud. This hypothesis, while creative, simply conflicts with the basic physics of gravity and sublimation, the process of a solid turning directly into a gas. When this strange visitor sped through our solar system, it left behind a profound scientific mystery. The data we collected was sharp, clear, and deeply confusing. It did not fit neatly into any of our established categories. In the quest to understand what we saw, the scientific community has proposed several explanations. These ideas range from the most conventional, stretching our existing models, to the most speculative, challenging our very assumptions about the universe and our place within it. The first and most conservative explanation is that this object was simply a natural comet, but one that was extremely unusual. Comets are a common explanation for interstellar objects because they are loosely bound to their home stars and are easily ejected into the vastness of space. This object, however, failed the most basic tests for being a comet. As a comet approaches a sun, its ice warms up and turns directly into gas, creating a visible cloud called a coma, which is then pushed back by solar wind to form a tail. This object had no tail. We detected no dust. We detected no water vapor or carbon monoxide. This is a critical problem because the object did accelerate. It pushed away from the sun with a force that was not caused by gravity. In a comet, this push is provided by the outgassing like steam from a kettle, acting as a small rocket engine. But this object had the push without the engine. To get the amount of acceleration we saw, it would have needed to shed a huge amount of its mass, perhaps 10% as it passed the sun. For this massive amount of gas to be completely invisible to our best telescopes is something that we have never seen before. To accept this explanation, we must accept that it is a comet with a shape unlike any comet we know, made of materials we cannot detect, that accelerates in a way that makes no sense. It requires us to accept not just one anomaly, but a whole chain of them. This is what scientists call the problem of fine-tuning. You have to invent too many special unknown properties to make the explanation fit the facts. This leads to the second framework, which tries to adjust the composition. Perhaps it was not a traditional comet. Maybe it was an asteroid. A rocky body with some kind of hidden engine. One proposal suggested it was an iceberg made of pure solid hydrogen. Hydrogen gas is invisible, so as a hydrogen iceberg neared the sun, it would evaporate and create a powerful invisible rocket push. This neatly explains the acceleration and the lack of a visible coma. However, this idea has its own serious problems. Hydrogen is the lightest element. For an object to be a solid chunk of hydrogen, it must be incredibly cold. Scientists who studied this calculated that a hydrogen iceberg would not survive the long journey through interstellar space. The faint warm light from distant stars would be enough to make it evaporate like an ice cube left on a counter for millennia. It would have fallen apart long before it ever reached us. A modification of this idea is that it was a nitrogen iceberg, a chunk of frozen nitrogen perhaps chipped off a large Pluto-like planet in another solar system. This is more plausible as nitrogen ice is much tougher and more stable than hydrogen ice. It could perhaps survive the journey, but this explanation still runs into the same problem as the weird comet, the shape. The data from its light, the way it flickered as it tumbled strongly, suggests it was not a lumpy potato-shaped chunk. It suggested a very extreme geometry. The object was likely flat like a pancake, or perhaps long and thin like a cigar. It seemed to have a length or width that was perhaps 10 times greater than its thickness. A random chunk of nitrogen ice broken off a planet would not naturally have this kind of extreme mathematically regular shape. This brings us to the third framework, that the object was a piece of cosmic debris. This idea suggests that a planet or a large moon in another star system drifted too close to its star and was ripped apart by the intense gravity. This tidal disruption event would shatter the planet and send its fragments flying across the galaxy. This object then could be a piece of an alien world's crust or mantle. This explanation is attractive because it could account for a dense rocky composition and explains why it was ejected into space. It is a violent and chaotic origin, but it crashes into the exact same wall as the other theories the shape. A planet that shatters does not create thin, flat, or precisely balanced shards. It creates irregular tumbling chunks. The problem of the object's geometric regularity remains. It seems to have a defined shape that is simply not produced by the chaotic forces of nature like gravity or explosions. We are therefore left in a difficult position. We have a set of high-quality data. We have several natural explanations, and all of the natural explanations fail to account for all the data. They each require us to believe in something we have never seen before: a comet that hides its tail, an iceberg that can survive for millions of years, or a planetary fragment shaped like a coin. This is where the fourth and most controversial framework appears. This is the taboo explanation, the one that most scientists are reluctant to even discuss in public. This is the idea that the object was not entirely natural. The central advocate for this line of thinking has been Avi Loeb, a professor from Harvard University. His approach is not based on a desire to find alien life. It is based on a principle of scientific honesty and data analysis. His argument is simple: when all natural possibilities require us to invent new, unproven, and highly unlikely types of objects, we must also be willing to consider the one explanation that does fit all the facts at once. What if the object is a piece of technology? This single idea resolves all the major problems instantly. Why did it have such an extreme, flat, pancake-like shape? A flat, thin surface is the most efficient shape for a solar sail. This is a form of technology which humans are already developing that uses the pressure from sunlight itself to move. The photons or particles of light from the sun literally push on the sail, accelerating it without any need for rocket fuel or gas. This perfectly explains the second mystery, the non-gravitational acceleration. The object sped up as it moved away from the sun because it was being pushed by sunlight, exactly as a solar sail is designed to do. It also explains the third mystery, the lack of a coma. If the object is not a melting iceberg, but a solid piece of advanced material, perhaps thin metal or composite, it would not outgas. It would not produce a tail of dust or water. The artificial hypothesis is the only one that explains the shape, the acceleration, and the lack of a coma with a single simple concept. In science, the simplest explanation that fits all the data is usually the preferred one. This is the principle of Occam's razor. In this case, the uncomfortable truth may be that the technology hypothesis is the simplest. The truly extraordinary claim Loeb argues is not that we spotted a piece of technology. The truly extraordinary claim is that nature produced a random comet or asteroid that perfectly mimics the design of an advanced solar sail. This brings us to the interpretation of the silence from many large scientific organizations. When the object was first discovered here, there was a flurry of excitement followed by a long, cautious and somewhat quiet period. This is often interpreted as appropriate scientific caution. The stigma against discussing aliens is immense. No scientist wants to be the one who cried extraterrestrial and be wrong, as it can be a career-ending mistake. This is known as the giggle factor. But there may be another, more profound interpretation of that silence. It may not have been just caution. It may have been genuine, paralyzing uncertainty. The data was so strange, so far outside the bounds of what was expected, that many scientists simply did not know what to say. They could not publish a paper claiming it was a comet because it so clearly was not a normal comet. They could not publish a paper saying it was an asteroid because they could not explain its acceleration. And they certainly could not publish a paper saying it was artificial. They were stuck. The silence was not the silence of consensus. It was the silence of confusion. It was the sound of a community confronting data that did not fit into any of their models of the universe. This single object in its brief passage did more than just confuse us. It held up a mirror to the scientific process. It challenged our willingness to follow the data even when it leads to conclusions that are uncomfortable, unpopular, or deeply disruptive to our sense of an empty, lifeless cosmos. What we saw was anomalous. We may never know for sure what it was, but the honesty of science demands that we do not rule out any possibility, no matter how profound its implications. This is not a drill. This is not a theoretical discussion or a debate for future historians. The entire conversation we have been having, all the speculation, the data, and the controversy boils down to this single critical moment in time. The most important part of this entire story is not what happened in the past, but what we choose to do in the immediate future. The time for passive observation and armchair analysis is over. We are now facing an urgent, non-negotiable deadline, and the clock is ticking. What makes this situation so intensely urgent is immediacy. The window of opportunity is not opening soon. It's open right now. As you read these words, the object in question is traversing our skies. Every single night that passes, every 24-hour rotation of our planet is another chance for data collection that vanishes forever. We are living inside the very moment that people will one day look back on and ask, what did they do? Did they even look? The universe does not operate on human schedules, and it will not wait for committees to form for funding to be approved or for academic papers to be peer-reviewed. This event is happening, and it is happening now. We have a precise and unforgiving timeline. This is not some vague, distant event. We have specific dates to anchor our efforts. The first critical date is November 11th. This date is marked as the resighting window. This is the moment the object is predicted to emerge into a favourable position for observation, a point where it becomes realistically detectable again for a dedicated network of observers. This is our starting gun. From November 11th onward, every night is a call to action. The second and most critical date is December 19th. This is the calculated point of closest approach. This is the peak of the event. On and around this date, the object will be at its nearest point to us, likely appearing at its brightest and largest in our telescopes. This is our prime time. This is the moment when we can gather the highest quality data, the clearest images, and the most definitive measurements. All preparations, all efforts to coordinate must be focused on being fully operational long before this mid-December peak. This brings us to the most sobering fact of all, the end. From the moment this observing campaign realistically begins on November the 11th, we have only about 6 weeks. 6 weeks until the object reaches its closest approach and then begins its rapid journey back out, fading quickly as it moves away from us. After this brief period, it will be gone. And gone in this context does not mean it will be back next year. It means it will be gone forever. It will disappear back into the deep void of space, moving too fast and too far away for any current technology to ever catch, follow, or study again. This is a single fleeting chance. We have 6 weeks to solve a mystery. 6 weeks to gather definitive empirical evidence. 6 weeks to either confirm the extraordinary claims or to definitively debunk them. After that, the window slams shut permanently. The opportunity will be lost to history. This is why we are issuing an urgent call for independent verification. We cannot wait for official institutions or government agencies to act. For reasons unknown, whether it's lack of interest, disbelief, or a deliberate choice, the mainstream astronomical community is silent. If we wait for them, we are choosing to fail. The only way the truth will be known is if we, the public, the passionate amateurs, the citizen scientists, take action ourselves. This is a call for crowdsourced science in its purest form. So how can you help? How can you participate in this historic hunt? You do not need to be a professional astronomer, but you do need the right tools and the right conditions. This is not an object you can see with your naked eye or a pair of binoculars. First, you needed a telescope of significant size. The baseline recommendation is an 8-inch telescope. This refers to the diameter of the main mirror. A larger mirror gathers more light, which is absolutely essential for seeing an object this faint. A smaller telescope will simply not be able to gather enough light to make it visible. An 8-inch model is widely considered the entry point for serious amateur astronomy, and many dedicated hobbyists own one. A 10-inch, 12-inch or larger instrument would be even better. Second, you need more than just an eyepiece, you need a camera. Our eyes are not good at seeing faint, faraway objects. A camera attached to the telescope can be set for a long exposure. This means it can stare at a patch of sky for 10-30 or even several hundred seconds at a time, allowing the faint light of the object to gradually build up on its sensor, eventually creating an image that our eyes could never see. You will need a good quality astronomy camera or a DSLR that can be attached to your telescope. Third, and this is just as important, you need dark skies. If you live in a city or a bright suburb, the light pollution, the glow from streetlights, buildings and cars will wash out the sky. It creates a bright fog that makes it impossible to see faint objects. You must be willing to take your equipment and drive. You need to get far away from city lights out into a rural area, a national park or a designated dark sky site where the Milky Way is clearly visible. This is a significant commitment, but it is the only way to succeed. With this equipment, you will need the object's coordinates, its precise location in the sky, for any given night, which are being shared online by the researchers tracking it. You will point your telescope to that exact spot, take a series of long exposure images, and see what you find. This brings us to the power of crowdsourced science. This is the moment where every individual with the right equipment becomes a vital part of a global scientific team. This is our chance to verify or to falsify these claims independently. Why is this so important? Because data from many people is infinitely more valuable than rumours from a few. If one person claims to see something, it can be dismissed. It could be a mistake, a sensor defect, a satellite, or even a hoax. But if 100 people scattered across a continent all point their telescopes at the same coordinates at the same time, and all of them capture an image of an object that is not supposed to be there, that is no longer a rumour. That is data. That is evidence. This is the very essence of the scientific method. We are not asking you to believe, we are asking you to look. We are asking you to test the hypothesis. Your contribution is valuable whether you find the object or not. If hundreds of qualified amateurs with good equipment follow the coordinates and find absolutely nothing night after night, that is also an incredibly important result. It would be strong evidence against the claims helping to debunk them. The goal is not to prove a wild theory, the goal is to find the truth, whatever that truth may be. This is your opportunity to participate. Instead of just reading about history, you can be part of making it. This open-source, decentralized approach is our greatest strength. It bypasses the silence of official channels. It makes censorship or dismissal impossible. If the data is gathered by the people and shared openly, it belongs to everyone. Now we must consider the alternative. We must think about the consequences of not acting. What happens if we let these 6 weeks slip by? What happens if we all assume that someone else is surely looking? If we do nothing, this object will make its closest approach on December the 19th. It will pass by us and it will disappear into the void forever. And we will be left with exactly what we have now. Unverified claims, grainy videos, and a loud echoing silence from official institutions. The mystery will never be solved. We will be stuck with this story for the rest of our lives, and we will pass it down to our children as another unexplained modern myth. It will become another Roswell, another what if, debated endlessly on podcasts and documentaries precisely because no one gathered the definitive data when they had the chance. The ambiguity will allow any theory to flourish from the mundane to the conspiratorial. Those who believe the extraordinary claims will say the evidence was ignored. Those who deny them will say it was a collective delusion, but no one will have the proof. We will be stuck in a permanent state of not knowing. The silence of the large institutions will be retroactively interpreted as proof of a cover-up, whether one existed or not. The failure to look will be seen as a failure of our curiosity, a failure of our scientific spirit. We will have let one of the potentially greatest mysteries of our time drift right past our front door simply because we were not organised or motivated enough to walk outside and look at it. We cannot let that happen. The choice is ours, and it is immediate. We have the timeline, we have the tools, we have the method, we have a 6-week window to answer a question that may change our understanding of the universe. Do not let this moment pass. If you have the equipment, use it. If you know someone with the equipment, share this information with them. Spread the word, coordinate, organise. The hunt is on and the clock is ticking. This is our one and only chance. Let us not be the generation that failed to look up. We are at the end of this particular journey, but in many ways we are just at the beginning of a much larger one. We've spent this time digging deep, looking at the evidence and asking the hard questions. Now we have to face the most difficult part, sorting out what we truly know from what we don't. The facts, as we can best determine them, are clear on one front. This object or this phenomenon is demonstrating behaviour that consistently defies our conventional explanations. We have testimony from credible witnesses, trained pilots and military personnel. We have sensor data, radar returns, and in some cases video footage that show capabilities we simply cannot replicate with public-known technology. We are talking about transmedium travel moving from the air to the water without slowing down as if the water offered no resistance. We are talking about instantaneous acceleration pulling what pilots would call impossibly high G-forces or gravitational forces that would crush any human occupant and tear apart any conventional aircraft. We are talking about moving with complete and utter silence, with no visible means of propulsion, no hot exhaust plumes, no wings and no rotors. These are the anomalies. These are the data points that have been recorded, discussed and analysed. They are not just stories, they are documented events that have puzzled our best and brightest. And yet for all that data, we are left with a void of equal or greater size. We have photographs, we have videos, but in an age of digital creation, where a skilled teenager can render a realistic spaceship in their bedroom, and now artificial intelligence can generate entire scenes from a simple text prompt, how do we know if what we are looking at is real? This is the crisis of evidence in the 21st century. A perfectly clear video is ironically almost more suspicious than a blurry, shaky one. We are left in a state of permanent uncertainty, unable to fully trust the very data we need to solve the puzzle. This leads us to the second and perhaps more troubling mystery, the silence. Why are the organisations we trust to monitor our skies, to protect our airspace and to conduct scientific inquiry so quiet? We can only speculate. Perhaps the simplest answer is the truest. They have no idea either. Admitting ignorance on such a fundamental level that objects are in our skies and we don't know what they are, where they are from or what they want is a difficult position for any official body. Or perhaps the answer is more mundane yet still secret. Perhaps this is all next-generation classified technology. Perhaps it's a new kind of drone, a breakthrough in propulsion from a rival power, or even our own black project technology being tested. In that case, the Scilabschutz is simply standard operating procedure. But then there is the other, more profound possibility, the one that lingers in the back of all our minds. What if they do know? What if the answer is so paradigm-shifting, so foundation-rattling that the powers that be have decided for whatever reason that we are not ready for it? This is a heavy accusation, and it is one we cannot prove, but the silence itself is a data point. It is a negative in our photograph, an absence of information that in itself tells a story. This official quiet, this pattern of no comment and classification forces us, the public, to take on the investigation ourselves. And that is what makes this entire subject so fundamentally different from anything else. This is not history. We are not looking back at a cold case. This isn't about digging up dusty files from 1947 or 1952. Those events are frozen in time, the evidence is degraded, and the witnesses are gone. What we are discussing is happening right now. This is a real-time investigation. The data is streaming in as we speak. A new report could be filed this very minute. A new piece of video could be uploaded tonight. You could walk outside after this and see it for yourself. This changes everything. It means we are not passive observers reading about the past. We are active participants in a story that is currently unfolding. The ending has not been written. We are living through the very moment that future historians, if they're ever allowed to tell the story, will look back on as the before. This immediacy, this sense that the mystery is in the present tense, adds a level of urgency and personal stake that no historical case ever could. It is not a whodunit, it is a what is it doing now? This is why your engagement with this channel, with this very story, is more important than you might think. When I ask you to like this video, to leave a comment, or to subscribe for more, it is not about vanity. It is not about metrics. It is about strategy. We are creating a public record. We are building a dataset of human interest. Every like is a signal to the algorithms that control what people see. It tells the platform, this matters. Show this to more people. It helps us break out of our bubble and reach individuals who might be curious but have not found this information yet. Every comment transforms this from a one-way lecture into a two-way conversation. It is where you share your own stories, your own sightings, your own theories. The comment section becomes a massive crowdsourced think tank, a place where one person's sighting in Brazil can be compared to another's in Japan. This is how we find patterns, and every subscription is a promise to stay engaged. It means you are part of this community, part of this ongoing effort. It means when the next piece of data drops, you will be here to help analyze it. By engaging, you are casting a vote. You are telling the world, I am paying attention and I want answers. But all of that, as important as it is only the first step. It is the digital side of the equation. The second and by far the most important appeal I have for you tonight is much simpler. It is the most fundamental act of a scientist, an investigator, or a simple curious human being. I'm asking you to please look up. That's it. Go outside. Get away from the city lights if you can. Learn the night sky. Learn what is supposed to be there. Download an application on your phone and identify the stars and planets. Know the bright, steady light of Jupiter or Venus. Learn the rhythm of the satellites, the predictable path of the International Space Station, the fleeting dash of a meteor. Learn what airplanes look like at night with their flashing red and green lights. Do this and you will arm yourself with the most powerful tool of all, a baseline. You will know your sky. And then when you see something that does not move like a planet, does not flash like an airplane, and does not follow the path of a satellite, you will know. You will be a credible witness, not just to me or to the world, but to yourself. We must become a planet of observers. We cannot and should not wait for an official announcement to tell us what is real. We must collect our own data. We must become a global network of sensors, millions of pairs of eyes all pointed at the sky, sharing what we see. This is the true meaning of citizen science. This is how we take control of the narrative. The sky belongs to all of us. The truth, whatever it may be, is out there, and it is available to anyone willing to simply look up and pay attention. We have explored the anomalies, we have questioned the silence, we understand this story is unfolding in real time. We have a plan to use our collective voice, and we have a mission to become our own primary sources. The path forward is uncertain, and the answers may not be what we expect, but we will walk it together with open eyes and an open mind. Stay curious, stay vigilant. Good night.